let's do one more example of finding the domain of a composite function. Just for fun, let's turn things around. Find the domain if g of x equals 1 over x plus 2 and f of x equals x plus 1. Okay, so notice the order we're doing things in this time. We're doing f first and plugging it into g instead of the other way around in the problem we just did. So that means we have to consider the domain of f of x and we have to consider the domain of g of f of x, but we never have to worry about the domain of g of x. So even though the domain of g of x would be that x cannot equal negative 2, we don't care. Doesn't matter in this problem. Okay, so we look at the domain of f of x, which is x plus 1 has to be greater than or equal to 0, right? So x is greater than or equal to negative 1. So that's for that part. Then we take this and plug it into here. So we do g of f of x, which means 1 over the square root of x plus 1 plus 2. I guess now we need to figure out what would make this denominator 0, right? So x plus 1 plus 2, we don't want it to be equal to 0. So we don't want x plus 1 to equal a negative 2. Well, let's see, let's square both sides, because that means that would happen when x equals 3, right? Let's try that. Plug in 3. 3 plus 1 is 4. Square root of 4 is 2, and 2 plus 2 is 4, not 0. Guess what? Because of that squared, because this is a plus, and because this answer is always going to be positive, this is not going to matter. So basically, this domain can be anything. We can plug anything for x that will work in the square root, so it has to fit within that, because we can't plug something in that's not going to work in the square root. But once we plug anything in that will work in that square root, so greater than or equal to negative 1, that will always be a positive answer. And then we add 2 to it, we will never get a 0 in the denominator. So this thing right here, so the domain of this doesn't matter, because it's the domain of this that matters, because that still is a restriction here as well. So domain x has to be greater than or equal to negative 1. These are a little bit tricky problems. They take a little bit of practice.